Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is longest common substring. First of all, let us start by understanding the question. What does question say? Given two strings, the task is to find the length of the longest common substring. So what is a substring? It is a continuous segment of a string. So we need to find what is the length of longest common subsequence. Common substring. Common substring means a substring which is present in both the strings S1 and S2. They might be present at different indexes, but the substrings are same. And when can I say two substrings are same? When each of their characters is same at every position, right? So there can be multiple common substrings. I need to tell the length of the longest common substring. Okay. For example, if my S1 is ABCDGH and S2 is ACDGHR, N is the length of S1 and M is the length of S2, then the output is 4. What is the highest length common substring? It is CDGH, right? That is given in the explanation. If we have ABC and ACB, then output is 1, because either only A is common or only B is common or only C is common. No more than one length substring is common, right? So the output is 1. You don't need to read input or print anything. Your task is to complete the function longest common substring, which takes the string S1 and S2 and their length N and M as input parameters and returns the length of the longest common substring in S1 and S2. The expected time complexity is N square M and N into M, and expected auxiliary space is also N into M. Okay. So if we think about solving this problem, then if what I need to find the length of the longest common substring. Now a substring is a continuous segment of a string. So in S1 and S2, if I look at common substrings, what are the common substrings? One is Z. Z is common in both. Then ZK is also present in both. They might be present at different indexes. Okay. Then A is common. Then AB is common. Then ABC is common. Then ABCD. This is common. So these are the common substrings. What is the length of the longest common substrings? It is 4. So 4 will be the answer for this question. Okay. Now how can we solve this question? So I can do it recursively by finding all possible variations, right? So I can call a recursion function which will take N and M as the parameters, and it will give me the length. Please hear it clearly. Here you might make a mistake between longest common subsequence and longest common substring. So here I can say that f of n comma m will give the length of the longest common substring, in which the substring in string 1 is ending at nth index and substring in string 2 is ending at the mth index. So either this nth character of the first string and mth character of the second string are same, or they are not. Right now, when I am telling that the length of the longest common substring ending at the nth position and in this ending at the mth position, let's say it is this, then all these characters are same and the last character is also same. So this will return me the length of the longest common substring ending at the nth and mth position if the nth and the mth character do not match. It means these two characters are not same. It means there is no longest common substring. There is no common substring ending at index n and index m for string 1 and string 2 respectively. So in this case, if S1 of n minus 1, that is the nth character of string 1, is not equal to S2 of m minus 1, then in this case I will say f of n comma m is 0. But if these two characters are same, then I can say f of n comma m is equals to f of n minus 1 comma m minus 1 plus 1. Because in two strings, if let's say this is the nth position and this is the mth position, here if the string is p and here also the character is p, then the length of the longest common substring ending at nth position of first string and mth position of second string are 1 plus. Why 1? Because p is common. So for p I have written 1 plus the length of the longest common substring ending at n minus 1 position of first string and m minus 1 position of second string. Can I write this recursive way? Right now you understand here f of n comma m is not giving me the length of the longest common substring considering the first n characters of first string and m characters of second string. That is not the case. It is giving me the length of the longest common substring ending specifically at nth position and at mth position. So out of all the possible values of f of ij, where I value lies between n and 1 and j value lies between m and 1. I need to for all values of f of ij, it means the length of the longest common substring ending at ith index of the first string and jth index of the second string, out of all f values the maximum will be my answer, because the longest common substring can end at any index. It can be any I index of first string and any j index of second string. So I want to do this with dynamic programming and I want to fill all possible values of n comma m. Why? Because here if you look here, then if I am talking about f of n minus 1 comma m minus 1, and let's say those two characters are also same, this position and this position character are also same, then this would be f of n minus 2 m minus 2 plus 1, right? So for this f of n comma m I need to calculate n minus 2 m minus 2, and for n minus 1 m minus 1 also I need to calculate it, right? So what I will do is I will store their values. That is, I have overlapping sub problems, so I will solve it using dynamic programming. So let us try to solve it using bottom up approach. Okay. So we will make a dynamic programming table and store all the values. Now what would be the table look like? I have two parameters n and m. So table I can take of n cross m size. Okay. So I will take a dp table of n plus 1 and m plus 1 size, where dp of ij will denote the length of the longest common substring ending at the ith index of the first string and jth index of the second string. So I need to fill this table. Okay, so and I will take one answer variable. Let me initialize it by 0, because in case no characters are common, my answer would be 0. Now first I will fill the base case. What would be the base case? If any of the string is empty, so in that case the common substring would be 0. So for I equals to 0, I is less than equal to n, I plus plus dp of I0 is equals to 0. Okay, because if the second string length is 0 I am considering, then there can be no common substring. Similarly, I can say for I equals to 0, I is less than equal to m, I plus plus dp of 0I is equals to 0. Means if there is no character of first string I am considering, then the common substring will be 0. Now let me fill the other values. So for I equals to 1, I is less than equal to n, I plus plus. For j equals to 1, j is less than equal to m, j plus plus. Now here I want to calculate dp of ij, which means the length of the longest common substring ending at ith position of first string and jth position of second string. So what I will check? I will check whether the ith character of first string and jth character of second string are same or not. If they are same, then I will use this formula. If they are different, then the answer would be 0. Because if the ith character and the jth character are different, then there can be no common substring ending at those two indexes, right? So if now ith character will be at which index? I minus 1. So if s1 of I minus 1 is not equal to s2 of j minus 1, then dp of ij is equals to 0. Else, if they are common, then I can say dp of ij is 1 plus. Why 1? Because ith and jth character are same, so 1 will be count for that. 1 plus length of the longest common substring ending at I minus 1 index and j minus 1 index of the first and second string respectively. And what I said, the longest common substring can end at any index I and any index j of first and second string, right? So at every step what I will do is I will say answer is equals to max of answer comma dp of ij, because the common substring ending at ith index and jth index can be the longest common substring. So I will always compare it with my answer, and this will give me my answer. Finally I will return it. The time complexity would be big O of n cross m, because that's the size of the loop, and auxiliary space will also be big O of n cross m, because we are taking a dp table of size n cross m. Okay, now let's look at the actual implementation and then submit the code. Okay, so if we look at the actual implementation, so I have taken one dp table and answer equals to 0, and then these are the base values. If the length of one of the string is 0, the common substring length is 0. And then for I equals to 1 to n, j equals to 1 to m, these are the two conditions where ith and jth character matches and where they do not match. And every time I will say answer is equal to max of answer comma dp of ij, and finally I will return the answer. So let's submit this code. Okay, so we have solved this question successfully. I hope you have understood this solution completely. Thank you.